We'll start our introduction to trig functions with a review of angles in standard position. So we'll just do a refresher of what this looks like for an angle in degrees. We start at 0 degrees, and when drawing an angle, we start with the initial arm on the positive x-axis, starting from the origin. We call this one the initial arm. And our terminal arm is where the angle ends. So we have an angle going in a counterclockwise direction. Let's label that one theta. It starts at the initial arm, it ends at the terminal arm. One full rotation all the way around all four quadrants would be 360 degrees. Halfway is 180, half of that is 90, and then halfway between 180 and 360 is 270. So this gives us an idea of where to put our different angles. We always start at the positive x-axis and we go counterclockwise for a positive angle. Let's just quickly rename these quadrants as well. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And we did this in pre-calculus 11 using degree measure, where one full rotation is 360 degrees, or 1 degree is 1 out of 360 of the rotation of a circle. Let's practice sketching a few angles in standard position. So I'm just going to zoom in on example 1. For 130 degrees, we know that will be between 90 and 180. It's close to the middle, but slightly closer to the 90. So we draw our initial arm, we draw our terminal arm, we start at the initial arm and go counterclockwise to the terminal arm. If you know the angle, you can label it with the angle, otherwise you can put a theta there. For a negative angle, we will start at 0, but we will go in the clockwise direction instead. So down here would be negative 90, and we're just past that a little bit. And we draw the arrow going in the other direction to show that we've gone in a negative direction. That's negative 100 degrees. If we have an angle that is larger than 360 degrees, we make one full rotation and then keep going a little bit. So for example, for 400 degrees, we do one full rotation of 360, and then we need to do an extra 40 degrees. The way we show we have a larger angle is we do one full spiral and then keep going up to the terminal arm. And that will be 400 degrees. Finally, negative, and with more than one rotation, we will do one full rotation of 360 and then keep going. If you're wondering, well, how much should we do? We'll do negative 530, add 360. To figure out how far should we go, what quadrant should we be in. It looks like we will be in quadrant 3. So let's do one full rotation going in the negative or clockwise direction, and then we keep going up to the terminal arm. We'll label that one negative 530 degrees. Where possible, I like to put an arrow on the end of the terminal arm, but it's not a deal breaker if you don't have it there. The really important one is that you should have this arrow and this spiral to show the full angle. Worth noting, we do have a reference angle there. In this case, we do negative 530 plus 360. Sounds like negative 170, so this reference angle is only 10 degrees. Just as a little reminder, reference angle is the distance between the closest x-axis here and the terminal arm. I'm going to take that away. We'll just keep the angle itself for now. All right, we're going to look at doing something similar, except in this unit, we are going to be looking at radian measure. Radian measure is another measure of angles. It's essentially a different unit instead of degrees. So to introduce radian measure, we're going to think about an arc length and the length traveling around a circle. So consider a circle where the radius is r units, meaning if you start from the center of the circle and you go up to the circle itself, that is a distance of r. One complete rotation in degrees is 360 degrees. The arc length for one complete rotation is 2 pi r, because essentially one full rotation around the circle is the circumference of the circle, or 2 pi r. What we do is we create a ratio of the arc length over the radius. So that is 2 pi r over r, which is just 2 pi. So the distance traveled around the circle entirely as an angle is 2 pi radians. As an angle in degrees, it's 360 degrees. So this kind of gives us a conversion factor. Usually we use the more common one of 180 degrees is equal to pi radians. The official definition of a radian is a unit of angular measure equal to the angle subtended at the center of a circle. So let's say if we go from here to there, it's talking about this angle here, by an arc length in length divided by the radius of the circle. This would give us this arc length here divided by the radius. The arc length is a fraction of 2 pi r, and we divide by r, so we get a fraction of 2 pi based on the angle. Before we start looking at measuring other angles, why don't we just start with some very basics. So in degrees, let's come in on this circle. In degrees, this was 0 degrees, 90, 180, and 270. And notice I'm being very careful about putting the degree symbol on that. If we measure this in radians, we still start at 0 radians. A full circle is 360 degrees. A full circle is also 2 pi in radians. The default for radians is we don't put a symbol for the unit. Half of a circular rotation is 180 degrees, that is pi radians. Half of that for 90 degrees is pi over 2 radians. And then halfway between pi and 2 pi is 3 pi over 2, or 1.5 times pi. So that gives us kind of an idea of what 2 pi radians looks like as one full rotation. Let's sketch some basic angles in standard position using radians, and then we'll practice converting back and forth a little bit. So we'll start with each angle and sketch in standard position. I do like to label just the first few times we do this. This is 0 and 2 pi. This is pi. This is pi over 2. 3 pi over 2, just so we have something to kind of reference to. And again, we're just trying to get as close as we can to be accurate. Pi over 2 is directly on the positive y-axis. So we start at our initial arm and we go up to the positive y-axis. That would be 90 degrees. It is also pi over 2 as an angle in radians. Pi over 3 is a little bit smaller. It's a third of pi instead of a half of pi. So it's still going to be in quadrant 1. It'll be about 2/3 of the way up. In fact, it's exactly 2/3 of the way up because it's also 60 degrees. This is pi over 3 as an angle. Let's also look at a couple of slightly more interesting examples. And again, we'll just put in, this is 0, pi, 3 pi over 2, pi over 2. For negative pi, we do the same thing. We go clockwise instead of counterclockwise. So we want to travel pi, or half of a full circle rotation, but we go clockwise for a negative angle. And for an angle that is bigger than 2 pi, so keep in mind that 9 pi over 4, 9 over 4 is 2 and 1/4. So we do an entire rotation for 2 pi, and then we need to do an extra 1/4 pi. That will be an extra 1/4 pi. So we do a full rotation of 2 pi, and then we keep going another quarter. That is 9 pi over 4. Do we kind of get the idea of how to measure a radian? So we're doing similar techniques to what we do with the degrees. We're just using a different unit to do the measurement now. All right, let's take a couple of angles in degrees and practice converting them into radians. So we know that 180 degrees is equal to pi in radians. Again, we don't usually do a unit for radians. You may sometimes see a little capital R there, but the default, if there is nothing written there, is that it will be in radians. This gives us a conversion factor because 180 degrees is equal to pi in radians. So if we start with an angle in degrees, we can multiply by pi in radians divided by 180 degrees to convert. What we like to do is keep an exact answer in terms of pi. So no decimals, no rounding. We'll just have a reduced fraction and you will see a pi in there somewhere. Let's do one with the units just to make this really, really clear. So if we start with 120 degrees, let's multiply by pi in radians over 180 degrees. So altogether, this is 120 degrees times pi being divided by 180 degrees. You can sort of think of it as the units are also dividing out. So we end up with units in radians, and then we reduce the 120 over 180, which becomes 2 over 3, and we have 2 pi over 3. Usually we're not as finicky about writing out the units once we start converting, so I would leave the 690 degrees, and then I would just write something like, times pi over 180 degrees. But then as soon as I rewrite it, I'll just do 690 pi over 180. And then we'll reduce, let's do this in a couple of steps, 69 pi over 18. And I think we can divide a 3 out of that, so 23 pi over 6. All right, if you're feeling pretty confident with that, you could pause and try to convert the next two on your own. Or if you'd like to, you can work ahead with me. So same idea for the next one, even though it's a negative angle, just keep in mind after you convert, it should still be negative. So multiply by pi over 180 degrees, negative 405 pi over 180. Looks like we can divide out 45 from that. So we're going to get a 9 pi over 4, and that is negative. Notice as I'm getting these final answers converted into radians, I'm not bothering to put a little r there. If we see no unit, we default to radians. That also means when you're writing an angle like 180, it's important to write it with the degree sign, because without the degree sign, it's just a very big angle in radians. All right, the last one is not in degrees, but it says that we have an angle that is 7/12 rotation. So that's not one full rotation, but that's 7 out of 12 of a rotation. So you can think of this as 7/12 of one full rotation, or 7/12 of 2 pi. So we can do 7 over 12 times 2 pi, and we reduce. Okay, that one will give us 7 pi over 6 radians. Great. Now let's look at some going in the other direction. So let's start with an angle in radians, and let's practice converting to degrees. So we can use the same idea, 180 degrees is equal to pi in radians. But if we're starting with radians, we would like to end with degrees. Whatever unit we want to end with is what goes on top of our conversion factor. So we multiply by 180 degrees over pi. And then we can just simply multiply for each of these. So we start with 7 pi over 6 times 180 degrees over pi. Notice when we do this, the pi's are actually going to divide out. I'll do this in a couple of steps. So this is 7 times 180 over 6, and then 180 over 6 is going to be 30, so 7 times 30 is 210 degrees. I probably should keep the degree sign in there just so we can see we're ending in degrees. All right, let's do the same thing with the next one, times 180 degrees divided by pi. Don't let this pi throw you off because it's not in the fraction. It is still considered in the numerator, so the pi's will divide out. And then the 180 and the 4 will as well. So we can do negative 3 times 45, or negative 135 degrees. Okay. If you do happen to drop the degree sign in there, it's not a huge deal as long as you remember to put it back in at the end. Ideally, you want to keep it all the way through. All right, same as before, you could pause and try the next two, or you can work through them with me. So 22 pi over 3. I'm noticing by looking at this that it is a very large angle, so it's also going to be a very large angle in degrees. So times 180 degrees over pi. This will be 22 times 180 degrees over 3 once we cancel out those pi's. And let's just multiply those out. We get 1,320 degrees. All right, the last one is in rotations again. So we can think of it the same way we did the example above this one. It is negative 13 over 6 of one full rotation. One full rotation in degrees is 360 degrees. So we'll do negative 13 over 6 times 360. And again, let's just multiply that out. And we get negative 780 degrees. All right, so we've done a little bit of practice converting back and forth. You want to get pretty comfortable doing this and also be a little bit careful about units and entering on your calculator now that we may be sometimes using degrees, sometimes using radians. Some radian measures to memorize or at least become very, very comfortable with. These are the ones that you'll want to start to recognize. So we know that 2 pi is equal to 360 degrees and pi is equal to 180 degrees. We can also divide this up into some very convenient angles. For example, pi over 2 is just 90 degrees. Or if we do pi over 3, that's 180 divided by 3, 60 degrees. Pi over 4 is 45 degrees. Pi over 6 is 30 degrees. And these are very helpful as they give you an idea for the conversion, but you will also notice if you look at these angles, these are the special angles that we use for finding exact values of trig ratios, 30, 45, and 60 from our special triangles. So you want to start to recognize these as well in their radian form. That way when we get to a point where you need to find an exact value, you know you have a special triangle that goes with this. We'll come back to special triangles a little bit later.